Hi, I'm Matt Adcock from CSIRO's Data 61 in Canberra, and I'm one of the organisers of this symposium. I'd like to start by acknowledging the Ngunnawal and Ngambri people as the traditional owners of the land we're meeting on today, and pay my respect to their elders past and present. Dr. Xavier Ho is a hybrid design and software researcher appointed at Monash Art, Design and Architecture. Prior to joining Monash, he led the graph visualization engineering team at CSIRO, designing visualizations for machine learning on networked data. He also served as an individual contributor for UX design and scientific visualization. His interest in the future of meetings lies at the intersection of human perception and attention and the effects of audio and atmosphere. Please join me in welcoming Dr. Xavier Ho.
The way we speak and hear has a dramatic impact in conversations. Can we improve it somehow? And what are the technologies on the horizon? In this video, I will talk about the complex nature of sound, how we can benefit from virtual surround audio online, and of course, what the future has in store for us meeting online. I want to set the record straight. Sound is richer in information than video is. If you're listening to this on mute, I would tell you that you're missing out, but you wouldn't know that. Remember those moments when you are doing a video call and the internet is slow? What can you do? You turn it into a phone call with no video. Knowing that how technology is shaping, we have seen just about the opposite. Microsoft Teams recently introduced a together mode that puts your colleagues and friends into an auditorium. And they've expanded into sports like basketball and wrestling. But it is a visual-only change. Everyone is still sounding like the same way, regardless if they sit in the first row or the back row. Microsoft says the together mode will combat Zoom fatigue, but I think we simply sit on chairs every day for far too long. Stretching every half an hour, making tea, or going for a walk every 2 or 3 hours will help more than how we deliver video meetings. I will show you a science experiments video about how we perceive sound. It's about popping balloons under 2 different conditions. Watch this orientation video at the National Center for Physical Acoustics at the University of Mississippi.
Acquire some data, all right, and pay attention to the way this balloon sounds. Okay? You guys remember what it sounded like out there?
Yeah.
All right, we're going to do it in here. You ready? Amazing how much of your everyday acoustic experience is really all about reflections of sound and not coming directly from the source.
This kind of experiment blew my mind. What we hear depends not only on the source of the sound, but also the environment. In online meetings, the position and type of microphones, as well as the speakers or headsets, also play a role. Here's something you probably don't think about every day. Humans are binaural creatures with 2 ears, but conference microphones are typically single channel. The microphone's audio is then mirrored to the headsets, which typically has a left and a right channel. This means that we always hear the person as if they're speaking directly in front of us, even if there are 50 people in the same video call. This probably contributes to why, among many other factors, online meetings are less natural than in real life. The thing is, we already have a technology and a scientific understanding down pat for the most part. Second Life and VR Chat are good examples to start talking about spatial audio. In Second Life and VR Chat, you meet people of all kinds in the virtual, and where they are in relation to you affects the way you can hear them. They could be to your right, behind you, or even far away. Their audio engines attenuate the intensity and shift the timings of left and right channels to what we call sound localization. It allows us to locate the sound. Sound localization was studied in 1907 by this guy, Lord Rayleigh XII, with a tuning fork. He called it the Duplex theory, about how intensity and timing of sound in the left and right ears are perceived. It's amazing that a game engine like Second Life was implemented a century later. But it is a simple theory that only works for 2 dimensions. In VR Chat, if someone is talking upstairs and you're standing right beneath them a level below, they sound like they're talking right inside your head. Have you ever wondered why our ears look so funny and different from the rest of the body? As it turns out, humans are able to figure out not only the horizontal direction of sounds, but also vertically as well, thanks to the funny shapes called the peanut. Well, technically our head and torso also affects how we hear things, but let's focus on the ears for this talk. In 1967, a study modeled the human ear to understand how sound localization happens, and the theory was that the various peaks and troughs allows different intensity and timing to be enough for us to figure out where the sound is coming from. This is known as the peanut filtering effect theory. This model lets us reconstruct the original sound as close as possible, or at least to a pair of generic ears, but it is not yet widely available. When the model first came out, they were very computationally expensive for real-time applications, like video and audio conferences. There was a breakthrough in a 2001 paper that brought real-time 3D spatial audio to life. The authors implemented their algorithm in a low-power, embedded processing chipsets. This breakthrough in technology flooded in new waves of possibilities. Fast forward to 2019, the popular Unreal Engine offered hardware-accelerated convolutional reverb sound effects. These advances in real-time sound effects are already here in video games and cinemas, but not video conferences yet. Before talking about what's coming to audio in the future, I want to highlight one thing, and that is the equipment we use to conduct online meetings. If you haven't already, do yourself and everyone else a favor and get a gaming or conference headset. For one, it's tax deductible if you use it for work. These things are far more comfortable than the in-ear iPod headsets. When you move your head around, their microphones scrape on your cloths and make a lot of noise. If you get a headset, not only will you be able to have comfortable paddings around your ears, you will also have a microphone that is close to your mouth. The golden rule in audio recording is always to place the microphone as close to the source as possible, and this is no exception. Also, headset microphones are designed to detect near audio sources only, so you won't need to worry about that your colleagues can hear your dogs in the other room. Just to be clear, I do want to see your furry animals in the house, and there's no need to apologize when they take the camera spotlight. Looking to the future, I am delighted to tell you that audio technology companies are working very hard to bring 3D spatial audio to online meetings. One of them, Dolby, is experimenting with a new model that improves multi-way conferences by virtually placing everyone else in a circle. Another company, Direct, is working on placing the audio cue to where the camera image is on screen, like the top left or the bottom right, allowing us to better intuitively understand and differentiate online conversations. According to Matthias Johannesson, Direct CEO, spatial audio works even better with a webcam doing live face orientation tracking. In a recent interview published on Forbes, Matthias is hopeful that spatial audio will be available in 2021 for online meetings. That future is not so far away from today. I, for one, welcome our new virtual spatial audio meeting experiences and encourage all of you to try them out when they're available. After all, we all want to sound and hear better in the current times. However, no algorithm will improve the experience of sound in online meetings if our rooms are noisy, the microphone is scraping against the cloths, or being too far away. You probably have experienced that sometimes if you speak too far away from a laptop, others cannot hear you. Using a headset solves this problem. So there are things we can do today while preparing for the future of natural 3D spatial audio in conferences. We need to increase our audio literacy and take the equipment a little more seriously. And the more serious we are about the quality of sound, the more signals it gives to video conferencing companies to take note and improve our hearing and speaking experiences, and hopefully giving us crisp, crystal clear audio quality in the future. Thank you for listening to my talk, and I hope you enjoy the rest of the conference.